Hi, and welcome to Complex Numbers or Imaginary Numbers, Day 1. As you can see, we are not yet done with radicals. We have what are called imaginary numbers, and imaginary numbers come from negatives under the radical. So the square root of -1 is equal to I. If I have I to the 0 power, anything to the 0 power is 1. I to the first power is I, because anything to the first power is itself. Then I have I squared, which is just like saying the square root of -1 times the square root of -1, which would just be -1. Because when we multiply two radicals together, they end up being the number that was underneath the radical. I to the third is like I to the first times I to the second. Because when I multiply, I add exponents, so 1 plus 2 is 3. I to the first is I. I to the second is -1. So I have negative I. I to the fourth is like saying I to the second times I to the second. So that would be -1 times -1, which is +1. I to the fifth is I squared times I to the third. So that is -1 times -I, which is +I. I to the sixth is I to the second times I to the fourth, which is -1 times 1, which is -1. Okay, and I to the seventh is I to the third times I to the fourth, which is equal to I to the third is -I, and I to the fourth is 1, so it's just -I. So if you look at our answers here, we have 1I, -1, -I, 1I, -1, -I. I have 4 different answers, and they just keep repeating themselves, and that's going to continue. So this would be 1I, -1, -I. 1I, -1, -I. That brings me to this circle I have here. This is our clock. We have 4 possible answers. We have 1, I, -1, -I. Starts with I to the 0, I to the first, I to the second, I to the third. So I can verify what I have here. I to the 8th is 0, 1, 2, 3, 4, 5, 6, 7, 8. I end up right here. Therefore, is equal to 1. I to the 9th, so 8 and 9 would be the first one. 10 to -1, 11, -I, 12, is 1. 13 is I. 14 goes down to negative I. 15, sorry, negative 1. And 15 goes to negative I if you use the clock. However, I'm not always going to want to sit there and count around my clock because I can get numbers that are very large, like I have here 100 or 214 or 273. So I need another method in order to find my answers. What I do is I take my exponent, which is 20, and I'm going to divide it by 4 because I have 4 possible choices, 1i, negative 1, and negative I. So I'm going to do a little bit of long division here. 20. And I'm going to divide it by 4. That goes in there 5 times. I have 20. My remainder is 0. My remainder is where my answer is at. So this would be equivalent to I to the 0, which is 1. If I do the same thing with 35, 4 goes into 35 8 times, and that is 32. When I subtract, I get 3. So I'm going to look for my remainder of 3. So it's I to the third, which is equal to negative I. 100, 4 goes into 100. 2, that's 8. 2, bring down the 0, 5, 20. My remainder, again, is 0. So this is equivalent to I to the 0 or 1. 214, well, 214 divided by 4, we have 5, 20, this is 0, down the 1, down the 4. 4 goes into 14 3 times. 3 times 4 is 12. And I have a remainder of 2. So this is equivalent to I squared, which is negative 1. And lastly, we have 273 divided by 4. 4 goes in there 6 times. 24, subtract 3. Bring down the 3. 4 goes into 32 8 times. Or 33 8 times because it's 32. When I subtract, I have 1. So it's equivalent to I to the first, which is just I. So those are pretty simple. It's just a matter of dividing by 4, and whatever your remainder is what your final answer is. Now, somebody might ask me, what happens if you get a remainder larger than 4? Well, then that means that you divided wrong. You will never have a remainder larger than 4. You can never have a remainder larger than the number that you're dividing by. So you need to take that into consideration. Okay, so let's solve some problems here. I have x squared minus 4 equals 0. Add 4 to both sides. So x squared is equal to 4. Take your square root. So x equals plus or minus 2. Do not forget your plus or minus. So here I'm going to subtract 1 from both sides. So x squared equals negative 1. Now I'm going to take the square root. Before we couldn't have this. Now it's okay. So I have x equals plus or minus the square root of negative 1. If you go back to the front of the page here, square root of negative 1 is I. So this becomes plus or minus I. Number 3, subtract 16 from both sides. So I have x squared equals negative 16. So I have x equals, because I'm solving, I still need to have my plus or minus. This is like saying negative 1 times 16. The square root of negative 1 is going to be I. The square root of 16 is 4, so it's plus or minus 4I. All right, now we need to simplify. Whenever I have a negative under the radical, my answer is going to have I in it. I cannot make my answer negative just because I have a negative under my radical. There are other reasons why I would have a negative. So, for example, number 4, the square root of negative 25 is simply 5i. The square root of 25 is 5. The square root of negative 1 is I, so it's 5i. For number 5, this is like saying negative 1 times 7, so it becomes I radical 7. For number 6, this is going to be negative 2 times the square root of negative 9 is 3i, so it's negative 6i. For number 7, we break this down as negative 1 times 4 times 3, so we have 2i radical 3. For number 8, only one of them is negative, and we have negative 36 over 49. So this is going to be 6i over 7. So for number 9, in order to add or subtract, we need to simplify our radicals first. So this becomes 8i radical 3, because I have to take the negative out, plus 27 is 9 times 3. So, and it being negative, I have 3i radical 3. These are like radicals because they both have an I and they both have a radical 3. So I just simply add the 8 and the 3 and I get 11I radical 3. Number 10 really isn't any different than what we were doing before. This becomes I radical 3. 8 simplifies to 4 times 2, so it's 2 radical 2. I need to multiply top and bottom by radical 2 because I cannot leave that in the denominator. So I have I radical 6 over 2 times, well, radical 2 times radical 2 is just 2, so 2 times 2 is 4. I cannot simplify that because I cannot divide under the radical if my 4 isn't under the radical. So I'll rewrite that for you. So it's I radical 6 over 4. For number 11, simplify our radicals. 8 is 4 times 2. With the negative, we bring an I. So it's 2I radical 2 minus 16 times 2 is 32. With the negative, it becomes 4I radical 2. And 200 is 100 times 2. With the negative, becomes negative 10I radical 2. All my radicals are like terms because they all have a radical 2 and they all have an I. So 2 minus 4 minus 10. So minus 4 minus 10 is minus 14. Plus 2, so it is a negative 12I radical 2. Oops, my mistake. I lied. That's a plus sign there. So that means my answer is going to be 2 and 10 is 12. 12 and 4 is 12 and negative 4, sorry, is 8. So it's 8I radical 2. So make sure you correct that. Adding and subtracting imaginary numbers, we cannot add unless we have like terms. I have I to the 6th, I to the 5th. They're not like terms, so we need to simplify them just like we were doing on the front. I to the 3rd is equivalent to, if you look back, you'll see that it is negative I. Or we can draw our clock here. 1I, negative 1, negative I to the 0, I to the 1st, I to the 2nd, I to the 3rd. So I to the 3rd is negative 1 plus 10 I to the 5th. Well, if this is the 3rd, then I have to have the 4th, and the 5th would be I to the 1st. So I have negative 6I plus 10I and they are like terms, and when I combine them, I get 4i. And for number 13, I will have 2 times I to the 5th simplified, we just did in the last problem, is I, minus I to the 9th. Either have to look back on the other page, or we have 3, 4, 5, 6, 7, 8, 9 brings me to I. So this is 2i minus I, which is going to leave me with just I. So really the only thing we've done is added a negative under the radical, which means I have an I in my answer. My answer can be negative or it can be positive, but the negative under the radical does not determine whether or not my answer is positive or negative. Another new thing we have is the fact that we have powers of I, or I raised to some power, 2, 3, 4, 5, 6, whatever it may be. And all you need to do is, when you're simplifying, divide by 4 and look at the remainder. The remainder tells you what power of I it will match up to.